Python large random integers and the precision of the Mersenne Twister. I am wondering what the precision of Python's random function means. It is described here. Almost all module functions depend on the basic function random, which generates a random float uniformly in the semi-open range, 0.0, 1.0. Python uses the Mersenne Twister as the core generator. It produces 53-bit precision floats and has a period of 219,937 to 1. This URL, access 20,120,727. What interests me is that I can generate very large random integers, long integers, that appear to have considerably more than 2 to the power of 53 precision. For instance, using IPython. I am wondering in what sense 53 bits is the precision limit of the random function. And concretely, if I ask Python to return pseudorandom numbers between 1 and some very large upper bound, is it not true that all integers in that range have an equal likelihood of being returned?
What Python does is generate 64 bits of randomness from calling the 32-bit version of MT19937 twice, but since that number is constrained to 0.0, 1.0, the result is constrained to 53 bits of precision, limitation of floating point format. Python random.py is capable of pulling bits from /dev/yourrandom or Windows cryptjon random, if supported, if you use the random.systemRandom class. Otherwise, it generates larger numbers by pulling successive bits from repeated calls to MT19937.
"53 bits is not an inherent limit in the generator, it is the amount that Python returns when you request a float, since floats have 53 bits of precision. You can get random integers directly using stuff like random.getRandBits. In more detail, the Mersenne Twister used in Python generates 32 bits at a time. The module code calls this twice and combines the results to generate a 53-bit float. If you call getRandBits, it will call the internal function as many times as necessary to generate k bits. The code for this can be found in here.
If you want to see more, please consider subscribing.